Okay, so the very last thing about circles has to do with circles in a coordinate plane. So when we are looking at that, we're looking at equations, we're looking at finding the center, we're looking at finding the diameter or radius. So the standard equation of a circle, we want to let x and y represent any point on a circle with the center hk and a radius r. So it's basically just a different version of Pythagorean theorem, but it's x minus h squared plus y minus k squared equals r squared. R squared being your radius, well, r being your radius, we're squaring our radius, and then h and k are the center of your circle. Notice that the general form of the equation is that x minus h, y minus k. So if your center is at -3, -4, in the equation it's going to be x plus 3, x plus y plus 4. If your center is at 1, 1, it's going to be x minus 1, y minus 1. So the signs are opposite of what the signs of your center are. So in 1 and 2, we're going to write this standard equation of the circle given the center and the radius. So remember, x minus h squared plus y minus k squared equals r squared. So we're plugging in our center for h and k. So x minus 0 squared plus y minus 0 squared equals our radius of 2.5 squared. So x minus 0 is just x, y minus 0 is just y. So x squared plus y squared, 2.5 squared is 6.25. So that would be our simplified equation. For number 2, we're just doing the same thing. So x minus a negative 2 squared plus y minus 5 squared equals our radius of 7 squared. So x minus a negative 2 becomes x plus 2 squared, then y minus 5 squared equals 49. We're not going to FOIL out the x plus 2 or the y minus 5. We're just going to leave it as is. Okay, so 3 and 4 are a little bit different because you're missing something that you need for your equation. So we're still using the general form of our circle. The point 3,4 is on the circle with a center of 1, 4. Write the standard equation of the circle. So we're starting just like we would before, center at 1, 4. So we can plug that 1, 4 in for h and k. And we need to solve for r squared. Well, we know this point 3,4 is on the circle, so we can plug that in for x and y, and then we can solve for r squared. So 3 minus 1 squared plus 4 minus 4 squared equals r squared. Well, 3 minus 1 is 2. 2 squared is 4. 4 minus 4 is 0. 0 squared is 0. So 4 equals r squared. Now, you can solve for r if you want to. Square root it, we'd get r equals 2. But we aren't asked for the radius, and for the equation, we need r squared. So if you stopped here, that would be perfectly fine. The last thing that you got to make sure you do is write your final equation, plugging in 4 for r squared. So we're doing the same thing for number 4. The point 4, 1 is on a circle with a center at 2, 3. Write the standard equation. So x minus 2 squared plus y minus 3 squared equals r squared. We're going to plug in 4, 1 for x and y. So 4 minus 2 squared plus 1 minus 3 squared equals r squared. 4 minus 2 is 2 squared. 1 minus 3 is negative 2 squared 2 squared is 4, negative 2 squared is 4. So we're going to have an r squared value of 8. So we're just going to write that final equation for our circle of x minus 2 squared plus y minus 3 squared equals 8. And for our last one, number 5, prove or disprove that the point 1 square root 5 lies on a circle centered at the origin containing the point 0, 1. So origin is 0, 0. So if we plug in what we know, we've got x minus 0 squared plus y minus 0 squared equals r squared, or just x squared plus y squared equals r squared. We know it contains the point 0, 1. So if I plug that in for x and y, 0 squared is 0, 1 squared is 1. So my equation, x squared plus y squared equals 1. If I plug in 1 square root 5 for x and y and it equals 1, it's on the circle. If it equals anything else, it's not. So 1 squared plus square root 5 squared, is that equal to 1? Well, 1 squared is 1. Square root 5 squared is 5. 1 plus 5 does not equal 1. So it's not on the circle. So that's it for circles. If you have questions, let me know. Your homework will be ready to go on Big Ideas.